Hello and welcome to Unit 10, Trig, our Day 7 notes. Specifically, we're going to talk about something brand new today called Law of Sines. And we're going to do this in a single triangle today because tomorrow we'll actually do double triangles. So Law of Sines, just with single triangles. Now, we have only done trigonometry in right triangles because, well, that's true for sine, cosine, and tangent. Technically, there's a relationship of sine that also exists, though, that has to do with proportions between angles and opposite sides. So law of sines looks exactly like this. I have A over the sine of A, B, so side B over the sine of angle B, and C over the sine of angle C. Oops, I wanted to change that color to make it cooler. There we go. All right, so ultimately it has to do with opposite sides and angles. So this proportion in the top is talking about sides, and that's where the lowercase letters are coming from. The uppercase letters are talking about angles. All right, so let's see how it works. A surveyor needs to determine the distance between 2 points A and B that lie on opposite banks of the river. Point C is chosen 160 meters from point A on the same side as the river as A. The measures of angles BAC and ACB are 41 and 55 respectively. Approximate the distance from A to B to the nearest meter. All right, so ultimately we're just looking for this distance right here. So this is not a right triangle. In fact, we can probably prove that by doing 41 plus 55, which is 96. We know there's 180 degrees in the triangle, so that means this missing angle here is 84 degrees. So definitely not a right triangle. But I can use law of sines to solve any triangle by using sides and opposite angle relationships. So I see that my side X is opposite this 55 degree angle. The 160 that they gave me is opposite the 84 degree angle. So using law of sines, I can say X over the sine of 55 equals 160, which is my side, over the sine of 84. And that's my setup. So again, sides over the sine of the opposite angle. Now in order to solve for x, we're just going to cross multiply to start. So I have x times the sine of 84 equals 160 times the sine of 55. Now in order to solve for x, I would then just divide by the sine of 84. All right, and then here's where we go to our calculator. Now, chances are you guys are going to use alpha y equals. I feel like you love doing it this way, so I'll do it as well. I'm going to type in 160 sine of 55. And then in the bottom, I have the sine of 84. So what did it say? To the nearest meter, I believe. To the nearest meter, so my final answer is 132. Now, just to show you, I really didn't have to use alpha y equals. I could do 160 sine of 55 in this example. Just make sure I close my parentheses and then divide it by the sine of 84, because order of operations will carry out by multiplying these and then dividing by the sine of 84. And you'll see I get the same answer, but either one is good. All right, let's try another question. So reading through here, they're giving me some information about my angle A, angle C, and AC. I want to find the length of AB. Now, I see that this side X is opposite the 50-degree angle. But this 30, which is side information they gave me, is opposite angle B, which I don't have. So I'm going to have to figure that out. Well, I know that 30 plus 50 is 80 degrees, and there's 180 degrees in a triangle, so that means angle B must be 100. All right, let's set it up and solve. So again, it's always the sides in the numerator, and then it's sine of the angle. All right, now we just cross multiply and solve. So I'm doing 13 sine of 50 divided by the sine of 100, and to the nearest tenth, you should get 10.1. All right, question 3. In triangle ABC, angle A is 30, A is 12, and B is 10. Find the measure of angle B to the nearest degree and include a diagram. Yeah, there's no way I'd solve this without a diagram personally. So let's draw a random triangle ABC. Angle A is 30 degrees. Now, notice how they said little a. Little a means it has to be opposite angle A. So that means that is 12 right there. Little b is a side length, which is opposite angle B. So this is 10. I want to find the measure of angle B, which is right here. Okay, so let's start looking at what we have law of sines wise. I have this 12, which is opposite angle 30. And I have this 10, which is opposite angle B, which is what I'm looking to solve. So let's set up a proportion. And I'll call this 10 over the sine of B, because again, we're looking for an angle here as opposed to a side. So this one's switching it up a little bit. Okay, in order to start to solve for angle B, I want to isolate that basically. So let's cross multiply to start. So I have 12 sine of angle B equals 10 sine of 30. Now, in order to get sine of B alone, I'm going to have to divide both sides by 12. Okay? So if I go to my calculator, I can do 10 sine of 30 and then divide that by 12. So 0.416 repeating, or 5/12. Let's leave it like that. Okay, now you guys did this before earlier in the unit. We're solving for an angle. So how do I undo sine? You can't divide by it because you can't divide by a function. So what I'm going to do is use my inverse sine. So remember, that's second sine in your calculator. So if I go to my calculator, second sine, 5/12. To the nearest degree, I'm getting 25 degrees as my final answer. All right, so I'm just going to put a little note here as a reminder. Solve angles with the inverse trigonometry. And inverse trigonometry is what this little -1 is referring to. Okay, so that's our first 3 examples of law of sines. The first 2 were solving for a missing side. Angle 3 was solving, or question 3 was solving for a missing angle. All right, let's go on to some more word problems. So on the next page. A ski lift begins at ground level 0.75 miles from the base of a mountain whose face has a 50-degree angle of elevation as shown in the accompanying diagram. So begins at ground level. So I'm already thinking, all right, this is 0.75. Okay, so label that in your picture. The ski lift ascends in a straight line at an angle of 20 degrees. Find the length of the ski lift from beginning of the ski lift to the top of the mountain to the nearest hundredth of a mile. So they're looking for x right here. So let's check out our law of sines. So a few things I'm going to have to find. This x is opposite this angle right here, which I don't know, but I can easily find because I know that's a line, which means it's 180 degrees. So that must be 130. Now this 0.75 that they gave me is opposite this angle right up here, which I also don't know. But if there's 180 degrees in a triangle and I have 130 and 20, that's 150 degrees right there. So that means this angle must be 30, right? 30 plus 20 is 50, plus 130 is 180 degrees. Okay, so I've successfully filled out the rest of the angles. So now I need to use law of sines to find x. So x is across from the sine of 130. And 0.75 is across from the sine of 30. Cross multiply. And then we divide. Okay, now I grab my calculator. So to the nearest hundredth, 1.15. All right, using your answer from part A, if the ski lift travels 5 miles per hour, approximately how many minutes will it take for a person to reach the top of the mountain and round to the nearest whole minute? So recall, and this is actually from middle school they taught you this, distance equals rate times time, which when I student taught in middle school, we called these dirt problems. Because dirt, T equals R times T. So they're telling me we are traveling up the ski lift, which we just found was a distance of 1.15. And we're traveling 5 miles per hour. So that's my rate. I'll kind of write miles per hour here for a second. I want to find out how much time passes. So if I were to solve for time, I would take that number and divide by 5. So 1.15 divided by 5. I'm getting 0.23. Here's the thing though. They want my answer in minutes. That doesn't make sense for minutes. Think about that. You travel up a ski lift 0.23 of a minute. Yeah, that does not make sense. But if it's in miles per hour, that means they're giving you 0.23 of an hour as a unit here. So you should be thinking, well, there's 60 minutes in 1 hour. So if you need to, because you're not as confident, set up a proportion to solve. I know 1 hour is 60 minutes. They solved, or we solved, for 0.23 of an hour, so how many minutes would that be? And you can cross multiply and solve. Some of you guys are going to be confident enough, though, that you're like, well, don't I just multiply by 60? That's exactly what you ultimately end up doing here. If I take 0.23 and I multiply by 60 because there's 60 minutes in an hour, that should give me my answer. So 0.23 times 60 is 13.8. So to the nearest whole minute, this is taking us 14 minutes to get up the ski lift. All right, we got just one more problem to go through. As shown in the accompanying diagram, two tracking stations A and B are on an east-west line, so side to side, 110 miles apart. A forest fire, oh no, is located at F. So here's your fire. Oh no, add a little yellow in there too. There's your forest fire. On a bearing of 42 degrees northeast of the station A and 15 degrees of a northeast station B. How far to the nearest mile is the fire from station A? So we're looking for this distance right here to start. So let's call that X. Okay, now we're going to have to definitely do a little bit of math to fill in some of our missing angles here. Now notice they have a 90 here. That means this whole angle is 90 plus 15, so 105 degrees. Now, this would also be 90 degrees if this is north and then this is east. So that means this must be 48 degrees, right, in order to make up the 90-degree angle. Now, in order to find my missing angle up here, again, I know there's 180 degrees in a triangle. So I can take away the 105 and I can take away the 48. And that missing angle at the top is 27 degrees. Okay, so now I have all my angles figured out. This 110 as a side length that they gave me is opposite the 27-degree angle. This X that I'm looking to find is opposite the 105-degree angle. Now I have my info to set up law of sines. So X over the sine of 105 equals 110 over the sine of 27. Now I cross multiply and solve. Okay, so ultimately I'm going to end up doing 110 times the sine of 105, but divided by the sine of 27, and to the nearest mile, 234 miles. And no, you don't have to label the unit, I just did because. Assuming the fire truck can travel 60 miles per hour, whoops, I meant to highlight that, not cross it off, 60 miles per hour, how long would it take the fire truck to reach the fire from station A? Use your answer from part A. Now we're just going to assume that the fire truck can travel on a straight path from A to F. So again, this is a dirt problem. D equals R times T. We just found the distance to be 234 miles. They can travel 60 miles per hour. So if I take my 234 and divide it by 60, oopsies, actually hit the division symbol, we ended up 3.9. Now again, this was miles per hour, so this is going to take them 3.9 hours in order to travel to the fire. Yikes. That's kind of a long time. All right, so that concludes our day 7 notes of law of sines with single triangles. Tomorrow, we're going to get into stuff where we're solving double triangle pictures. So a bit more exciting, in my opinion. All right, so your homework tonight is some law of sines, but also some mixed review of SOHCAHTOA because we got to make sure we're keeping up with some of the old stuff. All right, that's it.